Every parent's been there. You see a big project online, it looks amazing, your kid's excited, and you think, yeah, we could do that.
And then you start wondering how hard it really is to build it.
What you don't see is how often projects fall apart because people jump in before they're ready.
Or before they even know it's safe or possible to do.
Direct your attention to said screens. I believe that's North Korea.
That's what this episode is about. We're walking through how we decide where to start, why the helmet comes first, and how planning ahead helps us avoid some big mistakes. Hey, what's up guys? I'm Evan.
And I'm Ryan.
Welcome to the Bonding Blueprint.
If you've been following along the series, you might have noticed there was a bit of a gap in our 3D printing episodes, and that wasn't an accident.
Don't worry, we're still 3D printing stuff, just not the Iron Man suit yet.
We chose to take some time to learn the 3D printer and get comfortable with it, so we weren't guessing as much while printing the suit. We printed more Gridfinity storage to test various quality settings and making multicolor prints. I also learned the hard way not to rush, to double check my measurements, and to save my multicolor settings correctly before printing.
I printed a Fortnite crown so I could practice using the software more. Plus, it's pretty cool. We found out how not using enough wall thickness makes the print really easy to break.
We also made some functional prints, Christmas gifts, and some early exhaust parts for the printer.
All of that learning had one goal, basically making sure we knew what we were doing before starting the Iron Man suit. So when we started printing parts, we're not just guessing and hoping it works.
We chose to start with the helmet as our first project. It lets us test different filaments, print quality, proper sizing, sanding, painting, electronics, motors, and whether a project like this is even possible for a family.
If something goes wrong, at least it's not the whole suit. We can mess things up, figure out what went wrong, learn from our mistakes, and fix it up before we build everything else.
Before we print anything, we had to choose the files we were going to work with. I do know 3D modeling, but building a full suit from scratch would add a huge amount of time for something that's already been solved incredibly well. To start, we watched a lot of build videos, especially from Frankly Built and Emily the Engineer, along with looking at other various options online.
We talked about it ahead of time. We wanted files that people already built so we can get right into the fun and hands-on stuff.
We ended up buying the Iron Man Mark 6 suit by Walsh 3D, hosted on Wireframe 3D for $150. These files are engineered well, they're organized, modular, and designed for cosplay, meaning they're built to be worn and moved around in. From a modeling perspective, you really do get what you pay for with these files.
Everything's labeled and split up, so it's easier to understand. The files on the computer look really cool.
From the beginning, we knew the final suit parts would use higher-end materials. PLA is only intended for our test prints and for sizing.
PLA is cheap and great for testing scale before we print using the more expensive, good materials.
Early on in our journey, we added an air quality monitor in the print room. We wanted some real data to ensure what we're doing is safe, and we noticed something important.
Even with PLA and PETG, we saw little spikes sometimes. Not huge, but you could still see it.
We decided we'd be using ASA and TPU filament for the suit.
We knew we had to take ventilation seriously, as those filaments can put harmful particles in the air.
Even with the printer having an enclosure, when I started researching, I realized it's a more complicated problem than I originally expected. So, on the topic of air quality, I'm here in the print room by myself. Evan said this part of the video sounds boring and I should just do it myself. So anyways, we're tracking air quality in here with an AirThings 2960 View Plus. The mistake I made at first was assuming the solution was just adding an exhaust box on the back of the printer, attach a hose, pipe it out the window, and I'd be done. The problem is with some filaments, the back exhaust fan doesn't run all the time to keep the hot yet toxic air inside the printer enclosure, which can slowly creep into the room. It's not actually an airtight enclosure. So I need to pull the toxic air out of the printer, but slow enough to not reduce the temperature inside the printer. So what I'm aiming for is a small controlled amount of airflow, just enough that air wants to leave through the exhaust path instead of leaking into the room. I kept researching, and that's when I found a YouTube channel called Functional Print Friday. He does a really good job designing and testing practical shop upgrades. He shares the files he builds on his channel, and I grabbed his vent mod file for this printer. When the printer's exhaust fan isn't running, the back vents have flaps that stay mechanically closed, blocking my ability to pull the air out. His mod adds vent holes at the top using a honeycomb style cutout. This gives my exhaust fan somewhere to pull the air out of the printer even when the flaps are closed. I also added a honeycomb pattern using his tutorial to the back of this exhaust box and reprinted it. This gives me a place to check whether I'm pulling air properly. Once those are printed, I mounted it onto the printer, connected the hose which runs to my variable speed exhaust fan, which pushes the air out the window. Then I used a super simple test to set the fan speed. Grab a piece of paper towel, place it over the honeycomb holes in the back while the printer's running a print, and you hold it near the vent holes and slowly turn the exhaust fan up. You're looking for the moment when the paper towel gently sticks to the vent. That tells you you've got a small, steady pull. If the paper towel slams into the vent, that's a sign you're probably pulling too much air, and that can mess with the temperature and print quality. So I back down the fan until the paper towel stays just there on its own without getting yanked into the vent, and that's probably about the sweet spot. The big takeaway is if you're printing with other filament besides PLA in your house, make sure it's properly vented so your family isn't inhaling toxic fumes. I'm waiting on my ASA and TPU from Bamboo Labs so I can run some test prints and see how the air quality meter reacts with this setup. I'll report back later once I have those results. Hopefully this video demonstrates the need for proper planning and research before you get started with a big project like this one.
Even though I don't like waiting, I know planning things first helps everything go smoother. Are you thinking about starting a large project like this with your family, but not sure where to start? Visit our new Bonding Blueprint school community and we can help with your project planning. We'll be moving right into the helmet scaling, test fitting, and prepping for the real prints. So be sure to subscribe so you don't miss that. Thanks for watching and we'll see you in the next one.